as the activated sludge. Oxygen is pumped into the aeration tank for maintaining aerobic conditions. Because the process is in activated sludge process, this process is actually aerobic process. The bacteria involved in this decomposition needs oxygen. After few hours of agitation, the wastewater goes to secondary settling tank where solids settle at the bottom. The sludge is produced, dewatered and disposed of. The sludge can be used for lands or disposed of in ocean or used in croplands or pastures. Actually the sludge cake that I have said earlier are used as fertilizers in agricultural fields. Aerated lagoons. In your syllabus actually aerated lagoon is not there, so I am skipping it. This is also not there in your syllabus. Secondary treatment. Secondary treatment, there are two processes, activated sludge process and trickling filter. These are the two units which are in your syllabus. So, I have already said the activated sludge process. Now, trickling filter. Secondary treatment. Another unit is there in secondary treatment, that is trickling filter. Trickling filter does not filter the water. Actually, water runs over a plastic media and organisms clinging to the media remove organic matter from the water. That means the trickling filter is actually removing the organic matter from the sewage water or wastewater. It consists of a bed of crushed stones or pebbles covered with slime which consists of aerobic bacteria, algae, fungi, protozoa, worms and insect larvae. Now this trickling filter has the bacteria which are aerobic as well as anaerobic. That is the bacteria, there are another type of bacteria who are called facultative bacteria. That means these facultative bacteria can do their activity in presence of oxygen as well as in absence of oxygen. Sewage is degraded by the aerobic bacteria when it passes through the bed and is collected at the bottom of the filter. It helps in better removal of organic matter and also keeps the filter moist when the flow rate is slow. This is the trickling filter image. The final clarifiers remove additional sludge and further reduce suspended solids and chlorine. Secondary trickling filter operation. Types of attachment. Growth system. There is a sprinkler. This is called circular rotary arm distributor. This portion, the upper portion is called rotary arm distributor. And this trickling filter is circular. The tank is circular and there is a this portion is the rotary arm. This rotates. And from this pipe, from the in sedimentation tank, the effluent is entering into the trickling filter and then goes up, and they are perforated. These pipes are perforated. Through those perforation, the sewage is coming. See, it is given, and in the stone or rock beds, is coming out. In this way, this trickling filter is active. The wastewater is distributed over media upon which a biological film growth develops containing living organisms that break down organic material. The above layer consists of algae, and then the bacteria. First layer is this upper layer consists of algae, then heterogeneous bacteria, and then heterotrophic bacteria, and then autotrophic bacteria is there. Last is the tertiary treatment. In tertiary treatment, the sludge is treated, not the effluent water. The sludge is treated to provide final treatment stage to further improve the effluent quality before it is discharged to the receiving environment, that is sea, river, or lake, etc. Sand filtration removes residual suspended matter. Filtration over activated carbon remove residual matter. Importance of tertiary treatment. To remove total suspended solids and organic matter, those are present in effluents after secondary treatment. To remove specific organic and inorganic constituents from industrial effluent to make it suitable for reuse. To make treated wastewater suitable for land application purpose or directly discharge it into the water bodies like rivers, lakes, etc. To remove residual nutrients beyond what can be accomplished by earlier treatment methods. To remove pathogens from the secondary treatment treated effluents. To reduce TDS from the secondary treated effluent to meet reuse quality standards. In tertiary treatment, nutrient removal is done. Nutrient means ammonia and phosphorus. Then nitrification and denitrification is done. Then ion exchange process is involved and membrane process is involved. Aerobic biological process with different microbes where O2 is toxic, more certain. NO3 minus nitrite is converted to inert nitrogen. Again, phosphate, PO4 3 minus plus Al plus 3, it converts to AlPO4 into starch, aluminum phosphate. Addition to strip inert nitrogen, that is N2, and reoxygenate and add blue to reoxygenate and blue. Then phosphorus removal is done. Biological nitrification is done through the bacteria, Nitrosomonas and Nitrobacter. Then denitrification is also done through some another bacteria. Then ammonia is removed by air stripping and biological nitrification and denitrification process. And at last, the disinfection is done by chlorination, ozonation and UV regulation and ion exchange process. And these are another disinfection process. This is membrane filtration or ultrafiltration, nanofiltration. These are also disinfection process. Reverse osmosis, after that reverse osmosis is done. And then sand filtration. Then advanced tertiary treatment, which is not in your syllabus. So this is the end of the video series. Thank you.